Yes, next type of the problem, an aqueous solution of NaCl is prepared by dissolving 25 kg of NaCl in 100 kg of water. Determine weight percentage, mole percentage, composition of solution. Carefully read the problem. Aqueous solution. So we want to make a solution need solute and solvent. So in this problem, solute is a NaCl, is it correct? Solvent is a water. That is equal to solution. So basis value 100 kg only, is right? The 100 kg of water and also 25 kg of NaCl. So both components values are given. That is the basis value to find mole percentage and weight percentage. But what is the solution? So we want to calculate weight percentage and mole percentage. What formula we are going to use here? Is right? Yes. Solution part. We have the value NaCl weight and water weight. What about the solution weight? Solution means that is a total weight. So total weight is equal to WNaCl, weight of NaCl plus weight of water. That is 125 kg. The first part, weight percentage. Weight percentage of NaCl mean weight of NaCl divided by weight. Individual weight divided by total weight into 100. So individual weight you know, total weight also you know. Divide this value, find out weight percentage of NaCl. Similarly, the same procedure follow in a weight percentage of water. Weight percentage of water is equal to weight of water divided by total weight into 100. What about the other procedure? Once you know the weight percentage of one component, NaCl 20, okay. What about the remaining percentage? Total percentage 100. So total percentage 100 mean one component is a 20%. What about the other component? 100 minus 20 is equal to 80. No need to write this expression again. Weight percentage of water. So some step marks are there, is right. The step mark purpose only. So we are going to write all those steps, is right. Weight percentage of water. Otherwise simply we tell 100% minus 20% is equal to 80% of water is there, is right. Yes. So here weight percentage of water, that is equal to weight of water divided by total weight, that is 80. This is the first part is over. Second part, mole percentage. Once we are going to calculate the mole percentage, we need the number of moles value. So what is the relation number of moles and weight? Number of moles is equal to weight by molecular weight. But here we have number of moles of NaCl and water. So NaCl mean weight of NaCl divided by molecular weight of NaCl. Weight of NaCl already given value. Molecular weight of NaCl how to calculate? Na is a 23, Cl is a 35.5. Is it correct? So that is a 58.5. So find out the number of moles of NaCl. 0. Something is right. 0.427. Is it correct? Yes. Number of moles of water, the same procedure. Weight of water divided by molecular weight of water. Weight of water already given value. Molecular weight of water how will you calculate? 2 moles of hydrogen is present. 2 into 1 plus oxygen 16. Only one molecules are there. 16 plus 2, 18. So the 5.56 moles. Is it correct? That is a kilomole. So number of moles, total moles is right. Number of moles or total moles is equal to number of moles of NaCl plus number of moles of water. So totally 5.987 kilomole. This is the total moles. So now we are going to calculate mole percentage of NaCl. Individual mole divided by total mole into 100. 7.13. This is the same procedure here. The total percentage 100. 100 minus 7.13 is equal to remaining component. 92 point something is right. Yes. Otherwise you write. Why? Because the each and every problem having separate step marks. You follow the step, then only you get the correct marks. Is right. Otherwise you score the good marks. But you should follow the procedures. Is right. Mole percentage of water here. Number of moles of water divided by number of total moles. Is right. Into 100. 5.56 is given. 5.987 is the total. So finally we got the value 92.87. That is a mole percentage of water. Okay. This is the result. the component 2 component, weight percentage and mole percentage. This is 20, 80, this is 7.13, 92.97. Suppose your problem is right or wrong, you go to check whether it is coming 100% or not. Suppose you are not getting the 100%, you are done any mistake in your problem, you go to recheck the problem. Is it correct? This is a simple way in this subject. So each and every problem, so we should check the result. This is right or wrong. Individually we check. Then next problem, a liquid mixture of N-butane, pentane and hexane has following composition in weight percentage. NC4H10, N-butane 50%, N-pentane, there is C5H12 30%, hexane C6H14 20%. So this is the calculate weight fraction of each component, mole fraction of each component, mole percentage of each component, average molecular weight. Okay, so here 4 divisions are there. So very careful. When you are going to take this value, first you read the problem carefully. The problem is given weight percentage or mole percentage, first you read. But this problem they are given weight percentage, the question is the mole percentage. Sometimes, so they are checking your knowledge. Weight percentage is given in your problem, weight percentage also they are given in a question of the problem. So carefully read the problem. So in this problem weight percentage is given, but the question is a mole percentage. Okay, yes. To find, repeat the point, this is a weight fraction, and weight fraction and mole fraction difference mean I will mention there is a x dash. X dash is a weight fraction, mole fraction is a x, mole percentage. Then average molecular weight you know is right, there is a m average. If you want the formulas, you refer my previous lecture. There is a important terminologies used in unit 1. Yes, the basis of the problem, these are the values are given. NC4H10 50%, C5H12 30%, C6H14 20%. All are given weight percentage. So the total value you check 50 plus 30 plus 20, there is a 100 kg. Weight percentage mean I am directly take 100 kg. The weight of the each component I will mention. Percentage is converted into kg. 50 kg, 30 kg and 20 kg. What about the total weight? Total weight mean add the all the component. That is 100 kg. First part weight fraction. Weight fraction there is a x dash. Weight fraction mean individual weight divided by total weight. Suppose you want the weight percentage mean into 100. That's all. Weight fraction into 100 mean that is equal to weight percentage. Okay. So here weight fraction of C4H10 individual weight divided by total weight, there is a 0.5. Similarly C5H12 and C6H14 individual weight divided by total weight 0.3 and 0.2. So once again you see the problem carefully in weight fraction. So the addition of weight fraction values is equal to 1. Every time you must check your answers. 0.5 plus 0.3 plus 0.2 totally 1. Okay, so the addition of weight fraction or mole fraction value is compulsory equal to 1. Suppose you are not getting the value of 1, so you have done some mistake in your problem. This is very important in the problem. Mole fraction, we need the number of moles value. Number of moles is equal to weight by molecular weight. You know the formula is right. This is one simple formula involved in all the problem. Number of moles is equal to weight by molecular weight. Weight of C4H10 is given. Molecular weight of C4H10, 4 moles of carbon, 10 moles of hydrogen is there. 4 into 12 plus 10 into 1, so that is a 58. Divide these two values, you got the value of number of moles of NC4H10. So similarly NC5H12, the same formula, weight by molecular weight, but here only one different, molecular weight of C5H12. So the 5 carbon, 12 hydrogen, that is 72. So similarly C6H14, molecular weight only different, C6H14, but C6H14 weight is given in our problem, 20 is correct. So take that value, find out the number of moles. The total mole, adding these 3 values, that is a total moles of the problem. Next, mole fraction. The mole fraction means individual mole divided by total mole. All components are individual moles are calculated value. We substitute. The find out the individual moles of C4H10, C5H12, C6H14. Okay. So you see here 0.57 plus 0.275 plus 0.153 in the must is equal to 1. Suppose you are not getting the 1 value, you have done the mistake. You recheck the problem. Third part, mole percentage. Already I said the mole percentage or weight percentage mean mole fraction into 100 or weight fraction into 100. That is a mole percentage. So here mole percentage, mole fraction into 100, 57. So next one is a 27.5, the same mole fraction into 100. So here mole fraction all into 100, 15.3. So you check this value, all the are these values 27.5 plus 15.3, then again another component value, you check the value. So that is equal to 100. The percentage mean 100, approximately 100, 99.9, 99.8. Once you are not getting the percentage very close to the 100, you have done the mistake. So last part, average molecular weight. Average molecular weight, already I said, summation of mi into xi is correct. I is the ith component. The individual component molecular weight into mole fraction, the summation. So here three components are there. The first component x C4H10 into MC4H10 plus x C5H12 into M C5H12 plus x next component is right C6H14 into M C6H14. So all the values are This is mole fraction value, is it correct? 0.57, 0.275, 0.153, all the mole fraction values, not weight fraction. Be careful, this is a mole fraction. So substitute mole fraction value, find out the M average. Those 66.018. Okay, this is very important problem. Yeah. Last problem, there is a mixture of hydrogen and oxygen contain 11.1% hydrogen by weight. Calculate M average. Second one, partial pressure of oxygen and hydrogen at 100 kilopascal and 303 Kelvin. So to find M average and partial pressure of oxygen and hydrogen. Yeah, basis of this problem, 100 kg of mixture. So they are given only 11.1 kg of hydrogen mean remaining component oxygen is present, remaining amount oxygen is present. So the 88.9 kg of oxygen, 11.1 only given, the total kg is right 100 kg. So the remaining amount 88.9 oxygen is present. So molecular weight of oxygen, that is 32, hydrogen is 2. So the number of moles mean weight by molecular weight. Weight of oxygen is given, molecular weight of oxygen is known. Divide these two values, find out the number of moles of oxygen. Similarly, number of moles of hydrogen, weight of hydrogen divided by molecular weight of hydrogen is right. Yeah, this is the number of moles of each component. Total moles mean adding these two values, NO2 plus NH2. This is not the N2, this is a H2. Is it correct? Yes. Mole fraction of oxygen is equal to individual mole divided by total mole. The same formula. So here individual mole the same total moles are known. Find out the mole fraction value. Then X hydrogen also individual mole divided by total moles. Yeah, first one M average formula X oxygen, M oxygen plus X hydrogen into M hydrogen. Substitute all the values, all are known values. Find out M average 11.9. Second division is the partial pressure of the component. Partial pressure of oxygen is formula mole fraction of the oxygen into total pressure. This is a formula for partial pressure. So here this is 0.33, this is a mole fraction of the oxygen into pressure is a total pressure is given 100 is right, 33 kilopascal. Next one is the partial pressure of hydrogen, that is equal to mole fraction into total pressure 67 kilopascal. Only one hint in this problem, you notice that from the answer partial pressure of oxygen is equal to 33 kilopascal mean what about the total pressure? Total pressure is 100. So once you know the one component partial pressure of oxygen, easily find out the partial pressure of hydrogen. How? So we don't want to write the equation value. We have only the total pressure and partial pressure of oxygen. So what is the Dalton's law? Total pressure is equal to sum of the partial pressure of the component. So in this case total pressure P is equal to, so partial pressure of oxygen plus partial pressure of hydrogen. You know the total pressure 100 is right. So once you are find out the partial pressure of oxygen, 100 minus 33 is equal to what is that? 67 kilopascal. Directly you write. So, but mock basis you want to write, you should write the partial pressure of hydrogen equation, mole fraction into total pressure. Otherwise simply you check your answer, this is right or wrong. 33 plus 67, that is equal to how much? 100. This is your total pressure. Okay. Thank